Well, we're going to get on with it. First, I just wanted to say that there's some really great stuff in the forums. I see some of you guys are really active, and anyone who hasn't had time, I definitely would encourage you to spend the time, because there's some really great stuff and a lot of great question and answering going on in there, as well as a lot of good support by your fellow artists. So it's been really great to see some of the designs being made and coming to life. We got a couple of questions in this week to support, and some of them are going to have to be answered on paper or supporting material, but there are a couple of good questions I wanted to take a moment to answer here before we started. Questions about muscles and names are going to require diagrams, so I wasn't prepared ahead of time for those. But there's a good question here about pupils. Why, for example, some animals have vertical pupils, like some reptiles do, while some mammals, like goats, have horizontal pupils. And that actually has to do with how they function. Vertical pupils seem to do a better job of letting in lots of light. It's one way you can help with making sure you can see in dimmer conditions. Obviously, some animals, like cats, come up with a solution where they have a pupil that can expand and contract as is necessary. The horizontal pupil in goats is a fairly specialized adaptation to let the animal see a broader side-to-side range, probably at the cost of seeing resolution, like they don't see as many details, but what it does do is let them keep an eye out on predators over a wider field of view. So if you make a small animal that has to run away from whatever evil predatory creatures are in its environment, a horizontal pupil is not a bad way to go if you want to make it look kind of crazy, especially if it has to put its head down to eat a lot. There's another couple of good questions here about color vision. Lizards and birds see in color. In fact, lizards and birds see in more color than we can see. They actually see into the ultraviolet, the UV range, which means that their colors have additional information. Some insects also see in UV, and a funny thing about that is that a lot of white flowers that look very plain and we thought must compete just based on scent actually have really obvious patterns in UV light. So the problem wasn't that they were plain white flowers, it's that they weren't bothering to try to attract us. They're attracting things that could see the patterns in UV. And they're like almost outrageously patterned if you can use a camera with the appropriate filter and take a picture of them, with like basically landing strips like to guide the insects and stuff down. So although it's sort of always disconcerting to find out our limitations compared to other things, it comes down to the fact that even though humans see color really quite well by mammal standards, we're really quite bad at it in the bigger scheme of animals that are alive right now.
Hey, Scott.
Yeah, go ahead.
Yeah, I totally forgot about that. You jogged my memory on that flower UV color emission. I saw either a show or some internet photos. If you guys haven't seen this before, this UV color range that insects see, man, it is amazing. Search it out. I'll try to find some resources on what I saw and post it in the class forums or the class page. But it is phenomenal. Like, it'll change the way you look at the planet, basically.
Yeah. Turns out white flowers are like the gaudiest flowers.
And just the patterns, just like it shows a different image than what we see. It's crazy.
That'll be awesome. And then lastly, there's a question about compound eyes and whether they have any advantages over other types of eyes. The only significant advantage to compound eyes is that it's easier to make the visual surface, the surface that receives information, flex the other direction. If you look at insects, they're essentially like, some of them are basically balls with receptors on like 2/3 of the surface, and that means that even though their seeing resolution isn't so good, they can see motion and movement in darkness coming from a really wide range of field of view. Like even round eyes facing forward can see partially backwards just because they're spheres largely, and they've got the some of the light collecting nodes coming up the back and even partially over to the top. So that's the main advantage. Otherwise, by and large, compound eyes are not really as good as camera-style eyes if you can make them. So with that, Here we are in week 3. Yeah, Michael, it's not so much that the chemicals are different shaped, it's that the our retinas obviously are on the inside of a ball, and so can only see the light that comes in through our irises, whereas compound eyes place lots of little light collecting packets, if you will, on the outside of a surface, letting you shape that surface so a single eye can basically see more of the area around it potentially. They don't all do that, but they can. So. Okay, so week 3, hexapods. This is sort of our transition. The first 2 weeks were a lot of let's learn enough anatomy to be able to talk anatomy, guys. And I think there was a lot of information, but hopefully it didn't feel too much like school. But now we're going to start, I think, having fun. The last 3 weeks are all dedicated to solving sort of specific design problems that come up a whole lot. And we're going to get to apply that toolkit, to these specific issues. I did want to pause. I've already addressed some questions, but if you have any other questions from anatomy from last week or the week before, this would be a good time before we get into it to try to address them. Oh, thank you, Chris. I'm glad you did. All right. Well, with that deafening silence of keyboards, I will leap right in. So, today's agenda. We're going to actually do something unusual. Oh, I'm sorry, I didn't see the hand raised. Yeah, Michael, go ahead, please.
Hello. Can you hear me, Scott?
I can hear you, yep.
Okay. I've I've had conversations with people over the last few decades, not lately, because I've decided not to bring it up, but the majority of people believe that evolution is an external force, rather than what I believe is that each creature determines that it wants to evolve, and that the way you speak in class, it sounds like you pretty much have that same opinion. I don't know, because you say you know what I'm saying?
Yeah, I do know what you're saying. No, I hate to disappoint you. I'm simply speaking in shorthand.
Okay.
No, I'm a pretty traditional modern biologist in that sense. And I think the evidence. What's that?
Okay, I'm sorry. You don't believe that the individuals choose to adapt to their surroundings?
No, I do. I believe that in most cases those are hard to pass on, especially at a genetic level, to offspring. Now, to be fair, sociobiology is showing that, of course, things like cultural transmission are pretty awfully important in your success among social creatures, and that doesn't just mean humans. It turns out there's quite a few social creatures that can learn from either parents or others, and so
like the 100 monkey thing.
Yeah. So I'm
sorry. Go ahead.
No, it's okay. So, if you grow up, for example, in a culture where basketball is very important, and there are many such subcultures around the world, obviously, including in the United States, and that's literally like one of those things you do day in and day out. Physically speaking, you're going to tone certain muscles and reflexes at the expense of others, and that will definitely have an influence. The difference from that and the kind of normal adaptation that biologists outside of sociobiology worry about is that those other ones are things that can be passed on. Like if you were to transplant someone's kid from that environment to a very different environment, they would not automatically be better at basketball without that environmental influence. So it's not saying that it isn't important, it's just that they're studying a more fundamental, genetic-based inheritance.
Now, you don't believe... Okay, go ahead.
Well, there is one interesting mechanism which probably doesn't play an important role, but there is one surprisingly small Lamarckian role that's played in especially mammals, but also in other egg-laying creatures, which is that the initial divisions of the egg, especially again in mammals in placentals that give live birth, the initial cleavage patterns of the egg aren't based upon the DNA in the egg. They're based upon maternal RNA that's packed into the egg while it's getting ready to potentially be fertilized, shall we say.
Uh-huh.
And that means that changes in the instruction base in the RNA going in there do have an impact on the timing and patterning of the initial few cleavages. Now,
Okay.
there also are a lot of later effects to try to straighten out any deviations from the normal cleavage pattern in eggs, because if you get too different, you don't have a viable offspring for obvious reasons. But that is at least one hypothetical way that, like, you could have a more Lamarckian system influencing very early development. To my knowledge, that's the only one that actually has any
Validity.
tested validity. Yep.
So the RNA, which is the message compound, or whatever you call it,
Yep.
you're saying that it is possible that the mother's RNA, she could infuse the RNA with a pattern of some sort, which could cause a change in the evolution. Is that what you were?
Well, I'm talking about in the very early. So at most, it's
Right.
probably gonna like affect basic size or basic timing things early on. But yeah.
Uh-huh. Yeah. Okay. Well, that's pretty interesting. Thank you.
Yeah, absolutely. Okay. So back to hexapods. One thing we're gonna do today that I haven't done so far, because we haven't been talking about historical subjects, is we're going to briefly look at a history of hexapods in like culture and art. We won't spend a lot of time, but because those things tend to influence how we design things today, it's worth taking a brief look at them. And then, of course, we are going to look at common modern designs. And then specifically, we're going to look at what I like to call 3 classes. These are actually, in some cases, broader classes than you think, but I like to call them 6-legged horses, which we'll talk about as basically any of the big vertebrate-like hexapods running around in movies. They don't have to be horses. Centaurs, which definitely have their own problems. And then we're going to talk about flying hexapods, not in great depth because we'll be covering the flight aspect of them next week along with other flying critters, but I do want to talk about how the limbs could have effects to the body and the design implications there. We're also, at each of those stages, going to look at the problems with the current versions of these designs and potential solutions, that is, alternate ways we could tweak them so that you can come up with greater variety. It'll actually hopefully give you more freedom, because I think there's quite a lot of strictness accidentally placed on a lot of modern hexapod design that doesn't be there, and in some cases shouldn't even be there. And then finally, to conclude, we're going to have a breaking the mold section. There's a whole bunch of ideas that are really rarely explored when it comes to hexapods that should open up even more design possibilities. And some of them are I think they're less radical from a biological design point of view, but they're going to be very radical from a we don't really see them much in movies or TV or artwork today point of view. So let's just jump right on in. It probably will not surprise most of you to know that hexapods are really a pretty ancient design. Centaurs are particularly ancient, actually going all the way back to like some of the very first pottery-producing civilizations. It was thought to possibly relate to the first people who were not horseback riders who saw men on horseback. I'm not quite sure how it got from like the horse head and the human head down to just a human torso, but that's the common explanation. But we're talking about, 5 or 6 or more thousand years here. Obviously, dragons are quite ancient. Actually, not quite as ancient, but incredibly varied across cultures, maybe inspired by dinosaurs, which is interesting because of how often they seem to have lizard or mammal-like features in today's designs. Griffins are fairly ancient also, and griffins are particularly notable because they're one of the best cases where someone has made the case that they may have been inspired not just by fossils but by a very specific fossil. There's an entire set of papers and a book discussing this, that Protoceratops, which is found in Asia, where some of the earliest travelers from there to the west seem to have brought the griffin myth, have noted that the back half looks at least vaguely mammal-like if you're not really an anatomist. But the front half, of course, has a big hooked beak and then this big sort of inexplicable shield-like structure there, which, depending on how you feel about that, could seem like it could be either a mane or big ears. And outside of modern design, looking at past designs, actually really big backward-pointing ears are actually one of the common denominators of early griffin design, which is sort of fascinating. I don't really know where the wings and the eagle's claws would have come from, but it is worth noting, I think, that these hands would have looked pretty foreign in general, and the big, long scapula would have also, to people who mostly only see big mammals today. So between that and having a bird-like beak, it might have simply, upon retelling, have expanded the birdiness back as sort of a justification from the beak. Regardless, there's actually, if you look at the pattern of which the griffin myths first appear and spread and what's common to them earlier on, prior to, a galactic historical game of telephone being played, yeah, it does seem that there is reason to implicate Protoceratops, or a primitive horned dinosaur, in giving rise to it. One other fun tidbit, I don't know if this is special plating or not, but there are parts of Inner Mongolia where they find Protoceratops on nests occasionally, or nests, or at least what they assume are nests of them. Some of them we now know are oviraptor, but those nests frequently actually capture either gold and or fool's gold, because the dust that blows along settles out into the hollowed out areas, these mounds that with hollows on the top, for much the same reason anything drops out when wind blows particles across an opening, and then it gets slower as it goes across that. So you can actually find nests even today with like a smattering of gold dust sort of sheening in the bottom of them. And of course, griffins are almost universally known for hoarding and guarding treasure. So sort of a fascinating aside there. Obviously, this is, Pegasus, one of many winged horses in mythology. One thing that's to note, of course, is that mythology doesn't require anatomical accuracy, which is, okay. Of course, when you want to then kind of use them as a design basis and give rise to something that will look good in today's CGI-heavy, savvy viewership, then we have to take things into our own hands and go a little further. Obviously, iconography outside of Western cultures of hexapods or multiple-limbed icons are pretty common as well. Here's an interesting one. I haven't come up with a way to design this, so we won't be discussing it, but I did want to mention that Odin's horse in Norse mythology is thought to be an octopod, an 8-legged horse, but rather than trying to fix them to the sides, it's restored as having 2 sets of forelegs, like one to the inside of the other, and 2 sets of hind legs. So it's like 2 sets of 4 across, which I've thought a lot about, and I have not come up with a good way yet to actually make that work. But it's a fascinating example of like how you can easily turn a common idea sort of on its design head and come up with something very different looking. Of course, this was supposed to make it the fastest horse in the world, but in reality, without making the chest and the rump incredibly wide to basically allow for a whole other set of leg muscles, it would probably actually be the slowest horse in the world, because you'd be adding all that extra mass, that much extra power to drive it. Of course, there's also angels, which are hexapods, as well as flying demons. We're not going to. I did want to point out, interestingly, that winged angels are just not. They're more recent than you think. The first winged angel references come out at the very end of the 4th century. Prior to that, they're usually restored either as actually something you might recognize as demons earlier on, and later as kind of normal people hanging out. In this case, these are 3 angels being entertained by Abraham, who I believe is the gentleman coming out of the tent back there. Yeah, Tom, I will definitely go look into your griffin design. That's a promise. The only reason I mention that is because angels are very susceptible to modern expectations. We kind of want them nowadays to look very much like attractive babies or people with just like wings sticking out. In that case, you might as well just accept their fantasy nature. In fact, I would say if you have to do an angel-like creature where you have some design abilities, given the modern design expectation, you might want to like go the route that Blizzard did with their recent Diablo 3 game, where they, instead of trying to make it look like a plausible biological explanation, simply they embraced the magicness of it and went all out with these. Obviously, their TDs did more modeling here, let's say, than the artist did. But to go ahead and just go all out with a nice little multi-use wing-like iconography that's obviously driven by magic. If you do things that don't have to be so beholden to looking attractive and meeting current standards, though, a lot of winged demons are not supposed to do that. You could easily apply what we're going to talk about today and next week to like big, giant, humped muscles on the back. Sorry, this is a blurry image, but it was the best image I saw where somebody had really created a giant set of flight muscles on the back and to a degree on the front to help support these wings coming out the back. So if you're allowed to embrace the probable revulsion that the audience will feel from seeing a sort of mutilated hominoid anatomy, go for it. But 9 times out of 10, I think if you're making a CGI model of like an angel-like creature, you're pretty much going to be stuck duct taping wings onto a human-like model. Okay. So there's our brief history of most of the common winged creatures in history. Modern designs, well, let's just jump right into it. I already mentioned these, so let's talk about 6-legged horses. Now, you can take that literally. There are plenty of images of 6-legged horses out there. But what's common to these things is that most of the time this sort of standard hexapod design you'll see on aliens and anything else has 2 sets of forelimbs. I'm going to use this intentionally generic diagram today. That's a backbone and head. So in this case we'll have a mammal like free scapula and lower limb elements generalized, as well as a pelvis that barely attaches, and then generalized mammal hind limb elements. And basically all they're doing from a design point of view is taking that forelimb, duplicating it, and slapping it on the rib cage. If you wanted to do something that was like less generalized and more specific, here would be a bighorn sheep as a hexapod. It's essentially the same thing, but I want to be able to transform this into non-mammals easily. So that's what you get. You get your hexapods, and I don't mean that they have to be literal horses. The horse-like aliens ridden in Avatar, obviously, essentially 6-legged horses. And really, all the animals in Avatar that have 6 limbs basically do this. They almost all take the 4 limbs, and the way they made them work was to basically make the second set of 4 limbs mirror the front limb's motion almost exactly, but like delay. I forget if they delayed it or they sped it up by about 15%. So basically, all they were doing was working really hard to hide the 4 limbs during locomotion, and otherwise having them look kind of cool when they weren't really moving anywhere. John Carter of Mars, a lot of their aliens are also essentially 6-legged horses from a design point of view, like the great ape here. And is that a Woola? I just actually watched John Carter of Mars last week while prepping for this to see how they handle it. But that little cute, fast creature there. And even their aliens, their intelligent aliens, the Tharks, are basically upright 6-legged horses, if you will. They're really just an animal with 2 sets of shoulder blades and another set of arms therefore put on. And that's okay. Some problems you tend to see is like often the axial muscles that would have to combine them to the body get short shrift in a lot of these designs. But the biggest problem, I think, is that all these designs require your hexapods to be mammals, and I'll talk about why in just a sec. And then, of course, we've been talking about how that's okay if you're purposely making a mammal-like animal, but if you're not, these current designs really restrict you. They almost force you back into a mammal-like shoulder system, which is something we don't want to be beholden to if we can help it. And as I just said, people often don't spend enough time thinking about those torso muscles. We talked about like the latissimus dorsi that come off the back of the arm, as well as some of the muscles that come from the front of the shoulder blade that normally run up the neck. Well, they still need to have muscles, even on the second set of forelimbs, that affix it somehow to the torso. Because it's nothing but muscles holding on a set of shoulder blades like that are floating on the ribs. And it's really easy when you do this to get that photoshopped effect, to where like, yeah, I can clone things and make it sort of like confuse the eye, but there's no real detail there that would make it plausible. And especially when you start animating them, that can become more obvious. So how do we fix this? How can we move away? Well, the first thing we can do is explore what we run into if we change this up. For example, I think one thing you could do right away would be to change having a second forelimb to having a second hind limb. And you do actually see essentially that concept in this eight-legged creature design, again, from John Carter of Mars, where they've gotten a second set of hind limbs. However, that actually brings in mammals a very specific problem, which is that the mammal pelvis is really quite narrow with the hole it allows the guts to go through, and there's no way to make this pelvis sit on a rib cage. So mammals are actually sort of problematic in that way. The other thing you could do to make this into a dinosaur, there's a dinosaur forelimb shoved on, dinosaur hind limb shoved on. Of course, if we were going to really make this a dinosaur, it would have to have a bigger, heavier tail and a stouter set of vertebrae, but we're not going to worry about that. We're just talking in generalities here right now. If you take dinosaur limbs and musculature, you also run into an interesting problem if you try to duplicate the forelimb, if you try to make a six-legged dino horse, and that's because, unlike mammals, but like everything else, the front shoulder girdles, the shoulder blades, do not really make themselves amenable easily to this sort of a situation, and here's why. Remember, mammals, many of them separated almost completely up front, making it pretty easy to just slap on another set of shoulder blades further back. And even the mammals, like humans, that have at least a clavicle here, could still pretty easily get away with just having another set and then the clavicle running down to the sternum down here. So mammals make this easy, but dinosaurs do not. And here's both a photograph of a skeleton and the skeletal drawing of a animal called Caristenodes. This is kind of fuzzy, hence the drawing. But in both of them, hopefully you can see the shoulder blades come down. Most animals have a large coracoid bone that's actually separate but fused to it, which ties in with the sternum down below tightly. And then in the case of dinosaurs, these would be what were the clavicles but are now fused into a wishbone or a furcula, and that binds it up even more. So basically there's this whole front end to the animal, which means you can't just shove it back 5 vertebrae as a duplicate, or else you're completely cutting, you're bisecting the torso. So we're going to have to solve both of these problems. Here's a quick muscle rendition. Some of you are wondering how that goes together, and I'm sorry this isn't color-coded. But this is essentially the exact same thing with muscles drawn over it. You're going to have some of the pectoral muscles coming off the front there, as well as the deltoid muscles coming off the top there before you get to the arm muscles. And this is actually, this is the pectoralis also coming up down here. So you have a whole set of shoulder muscles up here, and then a whole set of pectoral muscles coming from down there. And they actually all run across to the outside and insert into this crest, which is called the delta pectoral crest because the deltoids and the pectoral muscles insert there. So that's how these come together. Also, I saw some questions about the sternocleidomastoideus, and that does actually come off of right up here on the shoulder and sternum area, much like it does in mammals, and that's this muscle running up in the front view that starts out very much on the bottom, but then as it goes up the neck, it kind of moves up towards the top of the head. You can't see it disappearing behind the head here. And that actually gives you that common contour you see where it starts at the bottom of the neck and in side view it would end up higher on the neck, exposing the sort of throat area under the skull. But the take-home message for hexapods is dinosaurs don't have a set of shoulders that are really good for duplicating. You could, of course, try to get around it the other way. You could try to duplicate the pelvis of the dinosaur, and you might be thinking, well, that's not going to work, Scott, because how do the guts get through? But surprisingly, dinosaurs with a really deep pelvis suggest a solution for this. If you look at the actual pelvis of a horned dinosaur, for example, you'll see that actually there's room here for the guts to go through that part that hangs down, and the front part also splits out quite wide. So your guts, which probably in these animals do end here, could move through here, especially if these bones were to bow out a little bit into sort of a pelvic belt, you might think of it. So that's one way to go ahead and solve this problem, is that then the guts could truly go through here, and you could have essentially 2 sets of hind leg muscles, and that would work okay from the torso's point of view. Okay, another solution is, of course, to mix and match. You could have a dinosaur front set of shoulders and hips, or whatever hips you want, and then you could go with a sort of mammal-like split-apart series for the second pair of forearms, if you really must do the 2 sets of forearms hexapod. And that would work okay functionally. I don't know what the argument is for how likely that would be to appear, but there's a lot of reasons to think hexapods probably wouldn't appear totally naturally anyhow, so I think you get a little bit of design freedom here as long as you're at least making the muscles and the bones actually work correctly. The other possibility, though, would be to actually not bother with a second set of shoulder blades at all. Don't make it a true six-legged horse. Actually attach the second set of forelimbs to an expanded shoulder blade. And in reality, the shoulder blade maybe should even extend a little bit further past so that there'd be room for more muscle, retracting muscles and a second set of triceps to go up there. Yeah, in fact, definitely should go a little further past than that. The only potential downside of this is that the second limbs are either going to have to be longer than the front ones are, which isn't the end of the world, or else you're going to have to sort of raise this up and make a very bird-like scapula where it comes up and then goes very horizontal after that towards the top, in which case the two sets of forelimbs could be similar heights. This solution, though, doesn't have this problem at all and has even more benefits if this second set of limbs doesn't need to touch the ground at all. So we'll come back to this, this design in a little bit. Okay, so before we move on to the next group, a quick design summary here. If you are making a mammal hexapod, you are going to have a lot of trouble if you try to use a second set of pelvies to add the limbs. They need to really modify the pelvis to where it's not really a mammalian pelvis anymore. Conversely, non-mammal hexapods can probably solve the pelvic problem, but are going to have a really, really tough time getting two sets of forelimbs if you want two sets of shoulder blades. And it's all because, you know, again, everything but mammals ties their shoulder blades together with the sternum up front. Usually the heart actually sits right up behind there and it protects the heart, and also provides support for the animals if they lie down or for the ones that are splay-limbed and are often resting on the ground. That said, there's really no reason you can't mix and match if you want more variety. You could still create a vaguely dinosaurish-like torso and set of fore and hind limbs and then, you know, stitch on a sort of pseudo-mammal-like pair of secondary shoulders. And, of course, as we mentioned at the end, we can also extend that single scapula back, don't even bother with a second set of shoulder blades, and simply put two forelimbs onto it. And I actually think that is probably the strongest design from a functional plausibility point of view for anything that isn't explicitly supposed to be a mammal with like two sets of forelimbs and shoulders. And as I said, we're gonna revisit that idea in a little bit when we get back to flying animals. But first, does anyone have any questions about this? That was a whole lot of rules, I know, kind of really fast. Anyone have questions or queries on that?
Make sure to give us a yes/no, guys, just so we can kind of cycle through and know whether we got to wait.
All right, Ishan has one, so I can wait for him. Okay, we have two good questions. Roman asked, the same way you can extend the scapula, could the same thing happen for the waist area? Yes, you absolutely could, but that would be a lot easier to do with a dinosaur-style pelvis where the pelvis is attached very well to the vertebral column with a whole lot of vertebrae, and where the pelvis is already quite elongated. Most mammal pelvises, I don't want to say you couldn't, but it would basically stop being a mammal pelvis if you started extending the vertebrae or the pelvis so much fore and aft that you would be able to fit it on. I will say this, if it's going to be a supporting limb, you know, a limb that'll help a six-legged running animal, you're going to have to not only extend the pelvis forward for or backward for it to attach, but you have to continue to extend it beyond that so you have enough leg muscle both between the two for the functions, as well as in front of or behind, depending on what you're extending it. So you're going to have to like extend it far enough for your second hip socket and then extend it beyond there so you have enough muscles to actually work that leg. So it could be done, but in a mammal you basically make it stop being a very mammal-like set of hips to do so, which is not a problem. They're totally okay. You make it kind of alien. So it could be done. I think it would be easier to pull off with shoulder blades because of how many of the key muscles do attach to the torso outside of like the biceps and the triceps, which are very linear in how they go up to the shoulder girdle region. But I don't think it's necessary, and it could be a lot of fun to explore that. Okay, on to Ishan's first question. As an extended scapula? Yeah, if you're going to do an extended scapula, you definitely are going to have two separate glenoid fossa, that is the joint where the arms attach, and you're definitely going to have two sets of deltoid muscles. Now there's probably two schools of thought about how you could do that. You could either make them completely separate, running kind of from the top of their own expanded parts of the scapula down, or conceivably, if you really wanted to try, you could actually have a muscle coming out, say, on top of the front set of deltoids, running to it, which would serve as sort of a deltoid slash pseudo-pectoral or even pseudo-sternocleidomastoideus, in the way it would help hold the whole thing on. And that would be an interesting way to make the muscles interact and sort of interdigitate, which would look cool. You'd still have to account for the muscles underneath. You'd still have to have the bulk there, but there's no reason you can't run one muscle over the top of another. We do it all the time in our bodies. It's a good question. Yeah, this would be a good moment for dirty scribbles, although usually when I talk about doing dirty scribbles at parties, I get funny looks, I just want to say. That's a great question. The lat muscle insertation, you really would need to have two sets of lat muscles, one for each of the limbs on that side. However, the front one, where do the lats go? I actually want to advocate almost that they would run up and originate partially from the front of the scapula behind it. Oh, you're doing the extended scapula, not the dual ones. In that case, I think you're going to actually want to run the first set of lats down and under the armpit of the second arm. Make it into like pectoralis muscles part 2 that are sort of ventrally oriented but also backwards oriented, curving over the various muscles on the side of the torso. And of course, it would largely disappear once it goes under the other arm, but that would at least let you get most of that backward motion that you really need to have to power the limb retraction. And then the second rear set of legs, obviously, you could run just like a normal set of lats backing up towards the pelvis. That's a really good question about muscles. Let's see, Jan. Yes, you could add limbs that don't have to actually be used as locomotion. That's a great point, Jan, and we'll come back to that point towards the end of today's lesson. But yes, you're absolutely correct. All right, anyone else? Moving on.